Hey everyone, welcome to my channel. Today we are going to learn how to create a convolutional neural network to classify digits from 0 to 9. We will write the training code from scratch and go step by step to train about 10,000 images of 10 different classes. Later we will create a testing script to use it along with the webcam. I will be sharing all the details including the versions of the packages and the parameters for the training. I upload videos on a weekly basis, so don't forget to like, comment and subscribe to keep getting the latest updates. So let's get started. We are going to start with importing the data, which is our images of the digits from 0 to 9. We will have folders for each class which contains about 1,000 images each. We will put all these images in a single list and create a corresponding list which will contain all the labels of the images. Then we will split the data into training, testing and validation. Later we will plot the training images distribution so that we can see if the data of each class is distributed equally. The images will be processed next to optimize for the training process. Then we will augment the images to make the data more generic. We will use functions such as rotation, translation, zoom and more. Next we will one-hot encode the matrix. Later we will create the model and start the training process. Once the process is done, we will plot the results. Finally, we will save the trained model and import it in a test script. Now this will be done to test it with a webcam. So before we begin, we are going to import all our packages. Now one of the questions I have been asked quite a bit is which package versions are you using? So I will be sharing the details of those as well. So let's do it together. We will go to settings and we will go to our project, and then we will start by adding our relevant libraries. So the first one will be OpenCV. So let's write down OpenCV and we will click on OpenCV Python. Now the version I am using is 4.2.032, which is the latest one. So we will install that. Next we are going to install numpy. Now the numpy I am using is the latest one, 1.18.1. Then we will install sklearn. Now the version for this, actually we don't have any version, so you just install. Then we have Keras. Now in Keras I am using 2.3.1. Then we have matplotlib, and for that we have the version 3.13, and then we have TensorFlow, which is probably the most controversial library, TensorFlow. Now this is 2.1.1, we have the latest version, but we are going to install 2.0.0. So sometimes this happens, it actually fails, so you don't have to worry, just close it, open it again, and you can go back to TensorFlow and as I mentioned before, we have to use 2.0.0, so we will install the package. So there we go, the package is now installed. If we go back to our settings and we will see here TensorFlow is now installed. So sometimes it doesn't work the first time, so you can try it again. So we are going to start with the training code first. The first thing we will need is the training set. So what we are looking at is my data, and we have 9 folders, actually 10 folders, and we need all the images in a form of a list. And later on we can use this list to actually send the data for training. So let's import the libraries required. So we will need numpy as np, we will need cv2, and we will also need os. So the first thing we will do is we will get the list of directories in our path. What it means is that we need the names of each one of these folders. So we need to know how many folders there are, and we need to know their names. So to do that, we are going to create my list is equals to os dot list of directories, and we are going to give it a path. Now this path, no, we don't need to define it like that. We can define it up here, so we can create a section here for all the settings and the initializations. So here we can say path is equals to my data. Okay, so this will create a list of all the folder names, and what we can do is we can print it out and we can see what happens. So let's run that, and there you go. So now we have the list of the names, so 0 1 2 3 till 9. And now what we can do is we need to know how many there are. So all we need to do is we can write length of my list, and we can check it again. So it is 10. So we have 10 folders, so this means we have 10 different classes. So we can write here number of classes is equals to length and the length of my list. So this we will use later on. So the spelling of classes are wrong. Okay. So next we are going to import all these images, and we are going to put them in a list. Now this list, we are going to call it, what do you want to call it? Let's call it images. So we will put all the images in one, list. So we need to iterate. So in order to iterate, we can say for x in range, we will say from 0 to our length, which is number of classes, so that we have. And then so now we need to get the names of each of the images inside our folders. So we have the list of the names of the folders, but inside these folders we have the names of the images. So if we have the names of the images, we can use the imRead function to read the images one by one, and then we can store them in a list. So in order to do that, we are going to use the same function as we did before, but this time we are going to say my pick list is equals to we are going to give the directory. Now this time the directory will not be our main directory, which is our not the main directory, sorry, the my data path. We are going to say in the my data, go into the 0 folder, and inside that, whatever names you find, put them in a list. So we need to say that we need to add here backslash plus the x. So we will convert it into string, and then we will put the x. So it will go, so first it will go to 0, then it will go to 1 2 3 4, and it will keep iterating. Now for every time it iterates, we need to read our image, and we need to store it in a list. So in order to do that, we will create another loop for y in pick list, my pick list. So for however many images we have, we are going to iterate through them and we are going to store them in a variable. So as we discussed, we can call that images. So let's write here images, and we will create a list, an empty list, and here we can say that our current image is equals to cv2 dot imread, and we will define the file name. Now our file name is our path plus the string. Our file name is our path plus the string plus the actual name of the image, so which is y. So we will add another slash and then we will add y. Okay, and this should work. Then we are going to resize our image. So the current image is equals to cv2.resize. Now this resizing we are doing because right now our images are 180 by 180. We need to reduce the size because 180 by 180 is too large for the network. We can still run it, but it will be very computationally expensive. So we will use 32 by 32 instead. So which image do we want to resize? We have to define that and the size. So we want to resize the current image, and once we have done that, we are just going to store it in the images dot append. So because it's a list, we will use append, and we will write current image. So yeah, that is about it. So what we can do, so next we have to save the corresponding ID, which is the class ID of each of these images. So we are going to create another matrix or another list with the name class number, and for example, when the x is 0, the class number will be 0. When the x is 1, the class number will be 1. So we will store the value of x, so it will be class number dot append, and then we will write the value of x. So now we will have all the images stored in a list, and we will have a corresponding class list in which all the IDs are stored. So what we can do is we can print out the x value so that we know which of the class folders are we in. So how many images we have imported. So we have 0, 1, 2, 3. So every time it loops, it adds on to the images, it will give us that value. So let's run that and see what happens. So yeah, so it goes to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So once it is done, what we can do is we can check how many images did we actually import. So we can write, because it is a list, we can check the length. So we can write print the length of our images. So if we do that, it will import all the images, and then it will tell us we have imported 10,160 images. And if we do the same thing with our class number, we should get the same result. And there you go. So we are getting the same result, 1,160. Now one thing that I don't like is that it is scrolling down, so it is a bit harder to see. So what we can do is we can print this with an end, and we can put equals to this. So this should put it in the horizontal direction instead of vertical. And then after that we can write here print, so that whatever we print afterwards does not come in front of that. And what else can we do? Okay, so in order to make it more intuitive, we can initially write, for example, here total total number of classes detected. Yeah, that will give us a good feedback. And then we can also write, when it starts, before it starts importing the images, we can write print, and then we can write importing classes. So I think that should look nice. Let's clear that out and let's run it again. So there you go, total number of classes detected 10, importing classes, and it imports one by one. Let's add some dots here. Dot, 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 dot. Okay. Yeah. So now it's importing the classes 1, 2, 3, 4, 5, 6, 7, 8, 9. And okay, so the next thing we have to do is we have to convert it into a numpy array. So we can take this list and convert it into numpy array. So we will say images is equals to numpy dot array and then images. That's it. And for class number, we will say the same. Class number is equals to numpy dot array and then class number. It's as simple as that. So now it is very easy to check the shape of this. So we can write print images dot shape and then print, or we can print it in front. Oh no, let's print it forward. Print class number dot shape. Okay, let's run that and see. So there you go. So now we can see actually what's going on behind the scenes. So we have 32 by 32 image of 3 channels. It means it's colored. And then of these images, we have 10,160 images of this size. So this is all in one matrix. And we have another matrix that has all the class numbers that are only values, and we can see that it matches with our images. So the class number size and the images size should match. To split the data, we are going to create a set of training, a set of testing, and a set of validation. So in order to do that, we need to create we need to import a different library or a package by the name sklearn. So let's import that. Import sklearn, and we need to import a very specific module from there, which is from model selection. We are going to import. Oops. This should be from. Then import train, test, and split. So we will write train. Oh, okay, there it is. So we are going to import that, and then we are going to use it to split our data. So let's name it first. So let's write here splitting the data. Okay. And what's wrong with this? Splitting. Spellings are right, I think. Splitting. I don't know why it's wrong. Anyways, so we will go to X. We will write here X train. Then we are going to write X test. And then we are going to write Y train. And then we are going to write Y test. Okay, so this is how you can split using the train test split function. Now if what it will ask you for the arrays that you want to split for, and you just input it and you give it a ratio of the splitting. So that means that we can say images, and it will split the images and then we can write class number, and it will split that too, and then you can keep adding. But what we need to do now is that we need to write down the test ratio. So for the test ratio, we have we will write test underscore size equals, let's say, 0.2. Now what does 0.2 mean? 0.2 means that your training will be 0.8% and your test will be 0.8 and your test will be 0.2. So 20% testing and 80% training. So instead of writing 0.2, we can write here test ratio, and the test ratio we can define in the settings so we can use it later on. Test ratio is equals to 0.2. Now let's go down here. We have the test ratio, so it should split this up. Now in order to see whether it has split it or not, we can write here x underscore train, and then we can do dot shape, and here we can write print. Okay, so before the split, this is your shape, and after the split, this is your shape for the train, and we can also do it for the test. So we can copy this and we can write here for the tests. Let's run that. There you go. So this is your main shape. So the number of images you already had, we already have before, and then this is our training set, and now this is our testing set. So you might ask, why do we need all of this? Well, we need this because we need to shuffle all the classes. If we just say that, okay, take the first 80% of the images, well, the first 80%, then it will be till 7. So from 0 to 7, we will get all the classes of 0 to 7, and we will not have anything in the training set for 8 and 9. And then in the testing set, we will only have 8 and 9, because that will be the split. So this is why we need an external package that will shuffle all the data, and it will divide it up, it will split it evenly for us so that we can train and we can test it accordingly. So next we are going to split it again because we want to do the validation as well. So we will write here, now from the X train we will take some more data and we will split it up. So we will take X train, and then we need X validation, X validation, and then we need Y train, and then Y validation. So we are going to use the same function, and this time we are going to split the X train, X terrain, and we are going to split the Y terrain. Okay, and the ratio we can write here, test ratio, we can write here validation ratio. We can copy this and we can add another variable here, and we can say 0.2. So this now will split it further. So we can check here X validation dot shape. Let's run that, and there you go. So this is your original set of data, then it was split for training, and then testing, and then validation. So what we are doing is we are taking the original value first, and we are dividing it into 80% and 20%, and then we are taking that 80% and then dividing that 80% again to 80% and 20%. So the largest one is our training, and then we have our testing, and then we have our validation. So next we are going to look at how many images we have for each class. So this is useful because we don't want to favor any of the classes by having more of the data from that class. So we can get that information from the Y-train, since it contains all the IDs of all the images. So X-train contains the actual images and Y-train contains the IDs of each image. So for example, we have lots of zeros, ones, twos, so we can find out the number of zeros we have, and then we can tell, okay, for the ID 0, this is how many images we have. So in order to do that, we are going to use the numpy function, numpy.where, and we are going to find in the Y-train, for example, number 0. So this will give us the index of where 0 is present. What do I mean by that? Let's find out. So we can just print this out. So there you go. So these are all the index values at which a 0 is present. For example, at index number 7, the class is 0. At index number 11, the class is 0, and so on. So all we need to do is we need to find how many of these total we have. So let's find out the total length of our 0, for example, IDs. So we can write here the index as this, and then we can put our length. So that will give us, I think I'm missing a bracket, and yes. Okay, so yes, so it gives us 638 images, and that is for the ID of 0. So again, what we can do is we can put this in a loop, and for each one of them we can print it out. So we can say for X in range of 0 to number of classes, we want to print this out, and we can change this to X. And there you go. So for each class, it's now giving us how many images we have. So what we can do next is, instead of printing it out, we need to save it in a variable. So we will call it number of samples is equals to, we can create a list, and then in that list we are going to append every time we get that. So number of samples dot append, and what do we need to append? We need to append this length. So once we are adding that, we do not need to print this out. So just to confirm, what we can do, we can just print out, once it's done, we can print out number of samples. So let's see how that works out. So it should give us a list of values, and there you go. So here we have how many images we have for each class. So this is 0, 1, 2, 3, and so on. So we have a total of 10 classes. So what we can do is we can create a bar chart, and that should give us some good information of how the images are distributed. So we can use matplotlib, and let's import that. So import matplotlib.pyplot and as plt. So matplotlib basically allows us to plot, as you can tell by its name. So we will use plt.figure. Now in the figure we are going to define the figure size, fig size, I think It's too much. Okay, fig, yes, fig size is equals to let's say 10 by 5, and then we are going to do plt dot bar, and we are going to give it a range. So the range, the range is from 0 to the number of classes, and then we are going to plot the number of samples for each one of them. And now we can add the title and the label. So plt dot title, title, and here we can say number of images for each class, and then in the plt dot x label we can add the class ID, and in here plt dot y label we can add the number of images. So we can write here number of images. So yeah, at the end we have to show it as well. So plt dot show, and let's run that. And there you go. So now all these values basically are plotting here with a bar chart, and we can see our distribution is quite even. I'm quite happy about the distribution. The number of images we have for each class is good enough to classify all of them evenly. Well, at least we can hope so. So let's move on. So the next step is to pre-process all the images. So we are going to create a function for that. We are going to define it as pre-processing, and in that we are going to request for an image. Now once we have that image, what are we going to do with it? The first thing we will do is we will convert it into grayscale. So image is equals to cv2.cvt color, and then we are going to define our image, and then cv2.color bgr to gray. Yes. The next step we will do is we are going to equalize our image. So basically what it does is it makes the lighting of the image distribute evenly. So let's equalize it using the cv2.equalize histogram method, and we just input the image. That's it. And then we are going to normalize our values. Now normalization means that now in grayscale values we have values from 0 to 255. Now what we want to do is we want to restrict it from 0 to 1. So let's do that. Image is equal, this is better for the training process. So image is equals to image divided by 255. So that is about it. And then in the end we are going to return our image as it is. So what we can do now is we can grab any of the images and we can test it out. So let's write down here, let's take one of the images, cv2.imshow, and here we are going to show that our pre-processed image, and it is img. So we need to define the img. Img is equals to pre-processing of our image, which will be, let's pick it from the X train, and let's say it is number 30. So once we have that, now these images are very small. These are 32 by 32. So what we can do is we can resize them so we can at least see them clearly. So we can say img resize, cv2.resize, and then img, and then we can define, let's say 300 by 300. This will help us see more clearly, and then we can write the cb2 dot wait key, because it will close if we don't put that. And there you go. So this is our distribution. So we close it, and there you go. This is our pre-processed image with the number 7. Looks good. Now, do we need all of this? I don't think so. So we can just comment this out. So now what we need to do is we need to pre-process all the images that we have in the XTrain array. So what we can do is we can use the Python function called map that will allow us to run a function over a list or an array of elements. So we can use map, and then we are going to write the name pre-processing, and then we will say where are the images, and the images are in the XTrain. So it will take this each element one by one, and it will send it to this function. Now it is doing that, but then it will give us a list of it, and then we need to store this list back to our XTrain variable or our XTrain array. So what we can do is we need to convert it back. If you remember in the beginning, once we created the list of images, then we had to convert it into a numpy array. So this is the same thing we are doing here. We are creating the list, and then we are converting it to numpy.array. So once we do that, we can store it back to our XTrain. So we can say XTrain is equals to this. So if we run that, it will pre-process them, but we won't see any output. So to see an output, what we can do, let's copy this. Let's copy it here. And what we can do is we can remove this, because we are already doing that, and then it will show us the pre-processed image. So let's run that. Okay, so this is our pre-processed image. Now one way to confirm it is by looking at the shape. So what we can do is we can print out the shape of one of the images. Let's remove that. So we can say that, for example, this is our image and we want to check the shape of it. So we can say here. So we can go back and write it here, and then we can check before the pre-processing and after the pre-processing. So in our pre-processing, we are converting it into grayscale. So that would mean that our image will have only one channel. So if we cross that out, yes. So here we have 3 and here we have only 1. So that gives us the pre-processed images. So we need to do this for all of them. So let's do it for the test and for the validation as well. So let's copy that, X test, and we will do it here as well, test, and then we have to do it for the validation, and then for the validation. Okay, so now that we have all of this done, next step is to add a depth of 1 in our images. Now this is required for the convolutional neural network to run properly. So we are going to add a depth. So we are going to reshape our images. So XTrain is equals to, we are going to say XTrain dot reshape reshape, and then we have to define the parameters. So what do we want it to reshape to? Now our initial parameters will remain the same. Now the initial parameters, what do I mean by that? We are going to take the size of our x train dot dot shape. We're going to take the shape of our x train. We're going to say that it is 0, it will remain 0. So the first three elements will remain the same. So the first, second and third elements will remain the same, whatever the size is. And then in the third one we will add 1. So it will create that depth. So the same thing, before we go forward, let's print it out and see if it works fine. So before that we can let's print out the complete shape. So x underscore train dot shape, and then we can say that we want to print it out and see what is the size. Now this is before the reshape, and this is why is it not going down? This is after the reshape. So let's see. And there you go. So before we did not have that depth of 1, now we have that depth of 1. So now we need to do this for all of them. By all of them I mean the test and the validation. So let's add those, and we can write here, why is it dropping that? So we can add here test. Then we can also add here tests, and we need to change for all of them. Test here as well, test. And then here is validation. Here is validation. So there you go. So next we are going to augment our images, which means we will add some zoom, some rotation, we will shift it, we'll add some translation. So all of this will make the data set more generic. So let's see how we can do that. So for that we have a module in Keras. So we will say from Keras dot preprocessing dot image imports, the name of the module is image data generator. Yes. So we are going to use that to generate some images that will be augmented. So let's say we will call it data generator is equals to image data generator, and then we need to define our parameters. So the first one, let's talk about the width. So we can shift the width. So we have to define the parameter of how much shift you want. So for example, if we write 0.1, that will give us 10%. Then we can write the same for the height. We can put it 10% as well. And then we will add the zoom range. Now the zoom range, if we are adding, for example, 10%, then it will zoom in 10% and zoom out 10%. So let's put 0.2, so 20%. Then we will add the shear range magnitude, which is again 10%. And then we will add the rotation. So rotation range, and this will be in degrees, so let's say 10 degrees. Next, we are going to help our image generator calculate some statistics before it actually performs the transformations. So in order to do that, we will add the datagen.fit, and then we will give it the parameter that we will be using, which is our xtrain. So basically what happens is that we do not generate these images before starting the training. We are generating them as we go along during the training process. So we want the generator to know a little bit about the data set before we actually send it for the training process. So the images that we will request will be in batches. So we will request a batch and it will augment and send it back. So we will look into this in more detail when we are actually requesting the images. So the next step is to one-hot encode our matrices. This is a necessary step for the network. So let's do that. So we will put our ytrain is equals to, so we need to import the module for this, and the module for this is in the keras dot utilities dot, and it is called to categorical. So we will go down, and here we are going to write it down to categorical. Then we have ytrain, and then we have the number of classes. So the same thing we will do for validation and testing. So this is validation, this is testing. So let's test. So if you are not familiar with what this means, maybe I'll make another video explaining in detail of what this is, but I'm assuming because this is an implementation video, I'm assuming you are familiar with the concept. So now we are going to create our model. So first we will define my model, and here we are going to define the number of filters. We'll put them as 60. Then the size of filter 1, we are going to define that 5 by 5. So this model is basically based on the Linnet model. So we are just writing down all the parameters that are required to create that model. So you can create your own, but we are going to use the Linnet model. So we'll write here size of filter 2 is 3 by 3. Then we have the size of pool, which will be 2 by 2, and the number of nodes. So all these parameters will be required once we start building our model. So let's start with that. So model is equals to sequential, and then we are going to create our first layer, which is the model dot add, and we are going to add a convolutional layer. So convolutional 2D, and we will define the number of filters and the size of the filters. So we will say number of filters, and then we will define the size of filters. So here we are using bigger filters by the size 5 by 5, and later on we are going to reduce the size to 3 by 3. So then we are going to input the shape. Input shape is equals to our, and then we will add the dimension of our image. So we can write 32. Actually, you know, we can write, let's declare a variable. We should write here image dimensions is equals to 32 by 32 by 3. So I think we use it somewhere else as well. Yeah, here. So we can just take these values from here. So we can say the first element and then the second element. So second element. Okay. So the same we will go down and do over here. So here we will have our input dimension. Okay, this is getting a little bit messy. So then we have input dimension 1, then we have the image dimensions element number 1, and then we have the 1. So basically this is the depth. So let me see the brackets. Okay, let's put it up here, and then we can put this down here, number of filters, and then we will add the activation function. Activation, let's put it as relu. Okay, so I hope there is no bracket missing. Yeah, it seems fine. Okay, so next we are going to add another one of these convolutional layers, and this time around we will keep everything pretty much the same, and but we don't need to define the dimension again. So I can leave it at that, and then we can close it back up here. Then we are going to add a pooling layer. So we will write model.add, so maximum pooling, and then we will define the pool size. So pool size is equals to size of our pool. Then we will add another convolutional layer. In fact, we will add two convolutional layers, 1 and 2. And for both of them, this time we are going to decrease the number of filters by half. So divided by 2, divided by 2. And then we are going to change the size of the filter to filter number 2. So this time we are using smaller filters. And again, we will add a pooling layer. And then we are going to add our first dropout layer. So model.add, then we are going to say dropout, and there we will add 0.5. So 0.5 means 50%, and then we are going to write here model.flatten.add, and then flatten. So this is the flattening layer. So then we will add our dense layer, and we will add model.add, and then we are going to write dense. Now in the dense layer we have to define the number of nodes. The number of nodes, as we have decided previously, it will be 500, and the activation we can keep it as relu. Then we will add another dropout layer. Now the dropout layers are basically helping you reduce the overfitting, and it's making it more generic. So at the end we are going to add another dense layer, which will be our final layer. So we will have the number of classes. So model.add, and then we will have the dense layer, and then we will add number of classes here. And this time around we will use the softmax function. So activation is equals to softmax. Okay, now this is our model. All we need to do now is to compile. So we will write model.compile, and we have to mention the optimizer, which is Adam, and the learning rate for it is 0.001, and the loss is, again, here we will write categorical cross entropy. So again, these parameters you can play around with, you can change them. If you are familiar with these parameters, you can change them as you wish. And I'm assuming this, because this is more of an implementation video, so I'm assuming you are familiar with the stuff. But later on I am planning to create another video tutorial explaining in depth of how CNN work and what are these parameters. So here we will write accuracy, hope the spellings are correct, and then we are going to return our model. Okay, so now we just need to call this function, and that will create our model. So we can say model is equals to my model, and once we call it, we can check the summary of this model. So we can write print model dot summary. Okay, so this should give us the summary of the model. So if we play it now, hopefully everything will work out fine. There we have this. We'll close it, and there you go. So here we have the parameters of our model. Now the last part will be to actually run the training, and to do that we are going to use model. We are going to use our model, and then we are going to use the fit generator. So if you remember, we discussed earlier in the augmentation part, where is it? Yeah, so in the augmentation part we are going to actually request the images from this data generator, so this image generator which will augment these images. So now we are going to request in batches that we need these images. So we are going to use the datagen.flow to actually get them, and here we have to define our images and then our labels or our IDs. So it is train, and then we need to define the batch size. So the batch size is let's put some variables here so we can use them later on. Batch size value, so batch size value as 50. Then we will also need the epochs value is equals to, let's say, 10. We will also need steps per epoch, and let's say 2000. So now we will define all of these here. So we are writing this here so that we can take all of this information up in our settings, so that we don't have to go and look for it in the code. So here we can write our batch size value. So next we will add the steps per epoch. So steps per epoch is equals to, wait, not this one. So it is steps per epoch is equals to steps per epoch, and then we have the epoch value. So we have, like, why is it like this? Should it be here? Okay, so epochs is equals to our epochs value, and we should write value here as well. Keep it constant. We can put that here, and then we are going to define our validation data. So validation data is equals to, oh, let's put it down, it doesn't get messy. So our validation data is x underscore validation and y underscore validation. Then the last thing, do we need shuffle? Yes, we do. So we will write here shuffle is equals to 1. Okay, so this will give us, this will start the training for us, and what we need, yeah, we need to save it. So we will write here history is equals to model.fit. So now this will save the parameters in the history variable so that we can check out later what happened during the training process. So before we plot anything, let's see if this actually runs properly. So by now it should start the training process, and then we can stop it and continue later on. So we have our figure, we'll close it, and there you go. So the training process starts, and it tells you it will take about 6 minutes to do one epoch, and it's giving you the accuracy and the loss as it goes along. So I'm going to stop it before my PC fries. Now now we will plot. We will plot once we are done with the training process. We want to know how was the loss, the variation in the loss, and how was the variation in the accuracy. So to do that, we are going to use our history that we stored in, and then to use that we are going to write plt figure, which is our matplotlib. We are going to write this figure, and then in our figure we are going to use what? Let's write that down, plt dot plot, and we are going to write our history dot history of the loss. And then we are also going to plot history of history, and then we are also going to plot the validation loss. Then we are going to add the legend so that we can differentiate. So then we are going to write training and validation. So training, and then we have validation. So we are going to make it look a little more professional by adding a title, and we'll put it as loss, and then in the X label we can write the number of epochs, or we can simply write epoch, and so that's about it. And then we are also going to plot a figure 2 in which we are going to plot the accuracy. So we will copy this and we'll paste it here. We'll write this as 2, and instead of the loss we are going to write accuracy, and we will copy that and we'll paste it right here, and then we are going to paste it right here. Okay, so in the title we should have a capital letter accuracy, and then to show it we have to use plt dot show. So then we can check out the score of our model. So we can write score is equals to model dot evaluate, and then we can write the X test and the Y test. So if you remember, we added these in the beginning of our code so that we can test it at the end, and we'll put this as 0. So to print the score out we can write print, and then we can write our test score basically equals to score. So the first element will be the test score, and the second element will be our accuracy. So we will print out the accuracy as well. So test accuracy. So remember, this data has not been seen by the model, the training, while it was training, so we should have a good picture of how our model would work from these score points. So we will write 1. So this will give us all the things that we require to actually train our model, and then to see the testing score. But one thing is missing, and that thing is the saving part. So we need to save this file so that we can use it in our testing model using a webcam or some images. So what we can do for that is we will use the pickle package. So if we go here, so we can write here import pickle. So if we go down, and we are going to store our model as a pickle object. So we will say pickle underscore out. This is just a variable name, and we will say open. We are going to say file type, sorry, the file name, and then what are we going to do with it. So we are going to say that we want to save it as model underscore trained dot p, and then we want to write it. So we will say wb. So basically that means write the bytes, and then we are going to write pickle pickle dot dump, and we will use our model, and then where do we want to dump it? In our pickle out. Wait, why are there two brackets? We need to remove. Okay, so then we need to close it. Pickle dot no, pickle out dot close. That should create our pickle object, and it should save it in our directory. So now we are going to, so I already have one here. I am going to move it, and so what I'm going to do is I'm going to train this for one epoch, and let's see how that runs. So to see if everything is working properly. Where did I put the variables? One thing is that we put our parameters somewhere. Yeah, we put our parameters here. Now these parameters should be right up in the settings so that we can change them easily whenever we want. So that's why we're going to put them here. And the batch size is 50 epochs. Let's put it 1 just to test it out, and I'm going to play it, and we will see if it saves properly and if it runs properly, and then we can go on the longer run. So hopefully it's loading all the images. It's showing us that the data is distributed evenly. We can close that. Then it starts the training process, and I will see you once it's done. So here are the results. I actually went back and changed the epoch to 2 so that we can get at least a line, not just some single points. So here we can see our accuracy plot and the loss plot, and here we have the final values. Now once we close it, we should get yeah, so there is your test score, and here is your test accuracy, and then at the end we should have our pickle file. So here I have saved it in A, the folder A. So if we open that, we have the model trained.p. So now we are heading towards the testing script. We will write some code so that we can send our new image to our model and let it classify which category it belongs to. In order to do that, we are going to import our packages first. So we need numpy, cv2, and pickle. So import numpy as np, then we need import cv2, and then we need import pickle. Then we are going to use our webcam. So we need the webcam object. So cap is equals to cv2.video capture, and my camera number will be at 1. So we can define the width and the height. Before we do that, we can add the area for our settings or the parameters up top. So we can write width is equals to 640, and then we can write height is equals to 480. So here we can write cap dot set, and our width is ID number 3. So we can write width and then cap dot set, and ID number 4 is the height, so height, and that should do it. So next we are going to unpickle our object, and we are going to put it in the variable model. So we will say that we are going to pickle in our model, and then we will do the same as we did before. We are going to write open, and then we will write the name of the model file. So model underscore trained trained dot p, and then this time we are going to write that we are going to read the bytes. So we will write model is equals to pickle dot load, and we are going to load our pickle in. So now we have the model that was trained in the variable model, and now we are going to send it an image through our webcam and see what model it classifies into. Okay, so we will write while true, and then we are going to write the first one is the success, and then the other one is the image original. Okay, so we are going to capture the read, and there you go. So next we are going to convert our image into a numpy array. So image is equals to numpy dot as array. That will convert it into an array of similar dimensions. So I am original, and then image is equals to, now we are going to resize our image because we want it 32 by 32. So we will write cv2 dot resize, and we are going to write 32 by 32, and which image we want to resize is the image itself. Okay, then we are going to send it to our pre-processing. So if you remember, if you go back, we have our resizing. After our resizing, yeah, this is our pre-processing. So we are going to copy this here, and now we are going to run the image through this pre-processing function. So image is equals to pre-processing and then image. So now we have our pre-processed image that is ready to go, almost ready to go for the prediction function. So we can output this to see how it looks like. cv2.imshow. Let's do this so that we can see if everything so far is going well. So processed image, and then we can write img. So now one thing is that this image is very small, so I don't want to run that like this because it will be very hard to grab. So I will make it a little bit bigger just for the sake of viewing, and then we can scale it up again. So model.trained, so spelling mistake probably somewhere, I think 1 N, yeah. Okay, yeah, so one thing I forgot is so when you are using the webcam, you have to add the function for breaking. The if statement for breaking. So when do we break? So we need to add the cv2.wait key, and we are going to say this, and we are going to say that whenever we find the Q the Q key pressed, we want to break. So Q, and then we have, so this is fairly common to use during webcams, and you can see here, and there you go. So this is the image coming live from my webcam. As you can see, there you go. So this is the one that we will try to detect, number 5. Okay, so far it's working well. We will go back to 32 by 32, and now we are going to just reshape the image before we send it to the predictor. So we have to reshape it, is equals to img.reshape, and then you will write 32 by 32 by 1. So once we have it in this form, we can send it to the predictor. So we can write here predict, and first thing we want to predict is the class ID. So we will say our class index is equals to model dot predict, and we want to predict the class through this image. So that will give us that, and let's convert it into an integer here, and now we can print it, class index. So let's run that. And there you go. So we are getting the class ID. So if I bring it in front of the number 5, you can see it changes to 5. Now it's changing to 8. So again, we are using it, we are using this model that was trained only for 2 epochs, so we don't expect it to be very accurate. It's just the concept. Later on I will train it again, and we can check out the video of how it works with better accuracy. So then once we have the class index, we are going to predict the the probability of it. So for that we will need prediction is equals to model dot predict, and we are going to predict our image using our image, and then we are going to get our probability value. So let's write prob, and probability value is equals to numpy dot max, and we are going to find the prediction. Okay, so it will give us the element with the highest number. So in the probability array, in the predictions array, it will give us the maximum one. So if you do not understand that, we can just print it out first so you can get the idea of predictions. So let me remove that, and let's run that. So here it's giving us the prediction of how likely we are getting each one of the classes. So right now it's giving, so we will have 10 values inside, and the highest value will be the one, the class that represents the current image. So all we need to do is we need to get the highest value. So the highest value will be our probability value coming from the maximum, and we can run that. Okay, let's remove this one, and here we have, okay, so there you go. So it's giving us the probability, and what we can do is we can put them together so it will be easier to see. Let's put the class index, and next to it we will put the probability. Class index, and we will put the probability. Okay, so now let me put it in front. Wait, what happened? Did it stop? Let me run that again. Okay, so now I will bring it in front of number 5, and there you go. So you are getting 5, and when you are getting it, it's 87% or around 90% sure that it is number 5. So that's how you can get the probability. And later on we can actually write this down on what do you call the image itself, so we can see what happens. And we can also say that if the probability of all of them is very low, so we can neglect that there is none of the classes are present. So to do that, we can simply write if our probability value is greater than a threshold. So that threshold we can define in our settings. Let's put it at 80%, or let's put it at 65%, because we are just using 2 epochs, so it's not a good idea to go very high. So so what we can do is we can write that if the threshold is above this, then only you need to display something, or yeah, we can put it on a text. So we can write cv2.put text, and let's put it on the original image. I am original, and then we are going to write the string. So let's write the class index. And do we need to add something to it? Let's not add anything. Let's keep it very simple, and then we can define the origin. So let's say it is 50 and 50. Okay, so right at the start, and then we have to define the font. So cv2.font, let's pick up one of the fonts, and then we have to define the scale. Let me bring it down. So we have to define the scale, so let's keep it at 1. The color, let's put it red, so 0 0 and then 255, and the thickness we can write as 1 as well. So if we get enough probability, we are going to show which class did we find. You know what, let's put the probability as well, plus the probability value, which is string, and we have the probability value here, and let's put a space in between so it's easier to read. Yeah, so it's getting very long. Let me put it down. Okay, so let's run that and see how that performs. So where is the image, the original image? Are we printing the image? No, we are not printing the original image, so we need to print it. So we are going to show cv2.imshow, and then we will write our original image, and then we are going to define our original img original. So this is our image, and there you go. So if we go really close, then it gives us the probability that is 5, and it is 0.7%, 0.9. Sometimes it's also thinking that it is 8. So I also have 2. Let's try that out. So if I move it around, oh, there you go. So we are getting it 0.9, 0.8% that it is 2. Well, that is good. So I have trained the model for 10 epochs now, and here are the results. As you can see, the accuracy is quite good, and you also have the loss plot, and you can see that is good as well. Here you can see the validation accuracy as 0.9969, which is again quite good. So in order to run the test part, we will close our windows. So let's close both the windows. So we'll close this and this, and then it will run the evaluation and it will give us the test score. So the test accuracy is 0.9975, which is fairly good. And once we are done with this, you can see we have now our model trained for 10 epochs. So I like to write underscore 10 so that we know that this was trained for 10 epochs. So now we are going to take this and we will run it in our test. So if we go back here, we will say it is in our main directory and it is called 10. So let me see my webcam, and it is connected. So let's run that and see. So I have printed out a few digits and let's see how it performs on that. So this one is handwritten and still it can detect. But as you can see, overall the accuracy is quite good. It is able to detect much better than the previous 2 epochs. So that's it for today's video. I hope you have learned something new. So if you haven't subscribed yet, please do and hit that like button. And if you have any comments, if you would like to know something else, please share that in the comments below, and I will see you in the next video.